Hey there, sixth graders. Today we're taking a look at Lesson 5, Exponents. So this one is a very important lesson, so make sure that you're actually paying attention. It says that our student goals are that you'll be able to discover that 3x is the same thing as x plus x plus x. It is not the same thing as x cubed, which is x times x times x. You'll also understand that a base number can be represented as a positive whole number, a positive fraction, or a positive decimal, and that for any number a, am is defined as the product of m factors of a. The number a is the base, and m is called the exponent or the power of a. Looking at this very first one, we see that it wants us to evaluate this, but the point is here, it wants us to pay attention to how we got our answer. So in this first one, go ahead and do all three of these. Now on this first one, I noticed that there are 10 fours. So I would multiply 10 times 4 and get 40. On the second one, I noticed that there are 5 nines, and 5 times 9 is 50. Or it's 45, what am I thinking? 45. And the last one is 5 tens, which is 50. Now as we look at the next, it wants you to write this expression in exponential form. We write the whole number here as our base, and we count how many we have, and that's our exponent. Again, on number 2, we write down our base, which we're talking about 2's, and our exponent is how many we are multiplying. Now going from we're in standard form here, and we changed it to exponential. On number 3, we're in exponential, and we need to go the other direction. We need to have 3 8s being multiplied. So it would be 8 times 8 times 8. And in number 4, we have 6 10s. 10 times 10 times 10 times 10 times 10 times 10. And number 5, we have again 3 G's being multiplied. Now our job is to go back 1 through 4 and evaluate them. What does evaluate mean? Yeah, it actually means to get the answer to that problem. So we need to make sure that you have your calculator and actually multiply 5 times 5 times 5, and you're going to do it 5 times. So pause the video and go and do that. Okay, on this very first one, as we multiplied it out, we should have gotten 3,125. For number 2, you should have gotten 16. Number 3 should be 512. Number 4 should be 1 million. That's 6 zeros. And number 5, instead of writing that out, we can't obviously solve it because we don't know what G is. But we do need to say, what is the difference between 3G and G cubed? Well, 3G is adding G plus G plus G. Whereas G cubed, so this one is 3 times G. So we're multiplying, okay? 3 times G, which is G plus G plus G. Over here, we have our G cubed is actually meaning G times G times G. So it's one is adding, one is multiplying, completely different. 6. 6 says write the expression in expanded form. We need to write it out the long way. So we're going to have 3.8 plus 3.8 plus 3.8. How many do we need? We need 4 of them, right? And then it said evaluate. So you're going to have to actually add these. Not add these. What am I adding? Multiply these. I'm sorry, guys. Multiply these. So 3.8 times 3.8 times 3.8. In your calculator, what do you get? Awesome. 208 and 5,136 10,000ths. Number 7. We need to write this one as an exponential form. So we're going to have 2.1, and it is squared because there's 2 of them. Probably should put that in parentheses. And 2.1 times 2.1 is 4.41. Number 8 is 0.75 cubed. There's 3 of them. Cubed, and our answer as we multiply that is 0.421875. Now, the base is a fraction. We can change our numbers here and have them as fractions. So that's what we need to do right here. Okay, we're going to go ahead and let's take number 7. We have 2 and 1/10, and we need that as a fraction. Well, to write 2.1 or 2 1/10 as a fraction, we need to move this decimal 1. So we have 21 tenths. Okay, 21 tenths. As we look at the whole problem, we have 21 tenths times 21 tenths because there's 2 of them. And as we multiply across, well, first we could write it as 21 tenths squared. And then as we multiply it across, notice we have to have 21 times 21, which is 441 in our numerator. And then we have 10 times 10, which is 100 in our denominator. And we still have our 2 out in front. Oh no, we're changing. We can actually do this right here and change this. 100 goes into 441 4 times, and then we have 441 over 100 left. So that would be our answer for number 7, I mean. And then for 8, we need to write 0.75 as a fraction. Well, think of money. 75 cents is what fraction? Let me pick something a little brighter. There we go. Yeah, 3/4. So we're going to have 3/4 times 3/4 times 3/4 because we have 3 of them. As we write that in exponential form, we would have 3/4 cubed. 3 times 3 is 9. 9 times 3 is 27 in our numerator and our denominator. 4 times 4 is 16, times 4 is 64. All right, let's look at number 9. It says write this expression in exponential form. Ready? We've got how many of them? 3, right? Good. So we're going to write 1/2, and it's going to be cubed. Look at our numerator. 1 times 1 is 1. 1 times 1 is still 1. in our denominator. 2 times 2 is 4. 4 times 2 is 8. And number 10, write this in expanded form and evaluate. So we have 2/3 being multiplied. Multiply across, and we get 4/9. I think that's it, guys. Head on back to the classroom.